So today we're moving on to 2.6. And so far, if I gave you a question like this, if I said something like 3x squared minus 4x minus 9 equals 0. What's the first way that I've been telling you guys you're supposed to try to solve this by?
GCF.
Not yet. I came up with a new name for it because of 2020 and the stuff that we're doing.
Quarantine.
Yeah, we're supposed to isolate the X. We're supposed to quarantine and get it by itself is the first way I would try to do this. Well, why do I realize I can't quarantine or get this X isolated?
There's 2 types of X's.
So I go, that's not good. So then second, now, Robert, what you're saying is a part of this process. I don't want to GCF necessarily, but I'm going to try to do what to this?
Factor.
Yes, that's the answer. I'm going to try to factor these things. And when I try to factor it, the first one I look at is a GCF, okay? They don't all have a GCF. Then I go to special case. I know this doesn't have a square root, so I know it's not a perfect square. I then try to do a equals 1, but a isn't 1, so I do the a doesn't equal 1 process, which tells me to multiply 3 times 9, which is 27. I need 2 numbers. This says different, so I subtract 2 numbers that multiply to 27, but subtract to 4. 3 times 9 is about the only way I can get there, and when I subtract those, I get to 6. What does that mean for me? Factoring is what?
No good.
No good. 3. What's the next thing I taught you yesterday?
Completing the square.
I'm going to try to complete the square. One of the things you're going to see me talk about tomorrow is, you know, if this has a square, or if this is a nice pretty number I can divide by 2, or if this is the square root, it's not. So we'll talk more about that tomorrow. Completing the square is no bueno. Okay. I feel like I've exhausted all of my tricks, things that are supposed to be quick and easy. So now I'm going to call out what I refer to as the big guy. I refer to him as the big guy because it's actually kind of a long process. And it's like me kind of, you know, if I get to the end of something and I'm kind of tired of playing around with someone, like, all right, fine. You asked for it. Now I'm going to get this thing out. The big guns, whatever you want to refer to it. This guy will always work. He solves every one of these quadratic equations. The only reason I don't use him first is because it is a long process and there is room for a lot of errors. Factoring, isolation, even completing the square should be faster than doing this quadratic. But when all else fails, I go to the quadratic. Does anyone know what the quadratic formula is? You should have seen it briefly in Algebra 1.
X equals opposite of b plus or minus the square root of b squared minus 4ac, everything over 2a.
And this looks very intimidating. Very good, Kelly. That's perfect. This looks very intimidating. It should not be. It shouldn't be. It's just you're going to plug in numbers. Remember when we gave you this, we called it ax squared plus. Does anyone remember what when I said a generic form of this? It's ax squared plus
bx.
Perfect. Plus
C.
And notice all these letters are the same letters that you see up here. Notice these letters are not letters you see on your report cards. Just kidding. All right, does that make sense?
Yeah.
So I'm going to use these A, this B, and this C to plug into this equation, and then all I do is do order of operations and solve for it. So for me, what I think the first process is to do is just to label my A, B, and C. So A would be 3. Does everybody understand that? B would be what?
-4.
-4.
Good. And C would be -9. Yep. Does that make sense? Now, the next thing I do, especially when I'm learning something, is I'm going to write the equation down generic, meaning I'm going to write it as opposite of b plus or minus square root of b squared minus 4ac all divided by 2a. Notice I did not even plug anything in. I just wrote the stinking formula down. The next thing I'm going to do is plug in. And when I plug in, I'm going to use parentheses. The only one I'm okay with you not using parentheses for is this one. Technically, I should write negative and then -4. Because that's the opposite. That's this negative right here. And then this negative is the one I just wrote right there. And what happens when you have two negatives and negative? What do they make?
Positive.
Or what I can see is the opposite of b. What's the opposite of -4? +4. So I'm okay with you plugging in like that. Plus or minus, then everything else I want you to use parentheses. So it would be -4 squared minus 4 times 3 times -9, all divided by 2 times 3. Does everybody understand what I've done so far?
Yep.
Yeah.
Now, please be careful. Why did I say to plug in using parentheses? If you have a calculator, does anyone have a calculator with them? It'd be nice to have that by your desk.
I do.
Okay, Kelly, put this in your calculator. Put this like this, exactly how I showed you. Put that in there and hit equals and tell me what number you get. Well, first off, what do you guys read this as?
-4 squared.
And that's wrong. That's actually not the way that you would read that. Robert, did you say you have a calculator?
Yeah.
Okay, if you did put in -4 times -4, what should be the answer, Robert?
Positive 16.
Okay, you put this in your calculator and you tell me what the answer for the calculator is.
-16.
Whoa. Why? Because this is actually read as the opposite of 4 squared. The calculator is actually doing this math correctly. This is really read as -1 times 4 squared, which the calculator does the squaring first, like it should, and then times by the -1. This is read as the opposite of 4 squared, which means you square the 4 first, then you apply the negative, and -16 is the correct answer. So notice, if you plug in without using the parentheses, what will you get as your answer for this front part?
-16.
And what answer are you supposed to get there?
16.
Do you see what I'm trying to bring your attention to in the little details that matter?
Yes. Big difference.
Big difference. And people don't point that stuff out enough, in my opinion. We don't bring that to your attentions. And I had like I said, a college professor and a high school teacher that brought all this stuff out. And it was like life-changing. I'm like, why has no one ever told me this kind of stuff? This makes it, it's like, whoa, holy crap. Now I see why I made little errors all throughout math. So right here, that's why we plug in using parentheses. That becomes a 16. And then I don't care if you think of this as 4 times 12, then times a -9, or what I would think of this as is a -4 times a 3, which is a -12, and then a -12 times a -9 is a positive 108. If you think of this as 4 times 3, you'll get 12. Then 12 times a -9 is a -108, but you'll end up with a minus a -108, which will kick back to a positive. Either way, you should still get this same thing I did. Does everybody understand what I just said there?
Yep.
Combine these, you get 4 plus or minus the square root of 124 over 6. Now, those of you who had me last quarter, you saw, I think it was last quarter, I think it was this one. We said, hey, we got to learn how to simplify these. 124 breaks down into 2 times 62, 2 times 31. So instead of rewriting it as the square root of 124, I can write it as the square root of 2 squared times 31. There's an imaginary 2 here. How many times does 2 go into that? That tells me I can get a 2 out, but the 31 has to stay inside. And so I end up with 4 plus or minus, instead of the square root of 24, that's simplified to as 2 square roots of 31. These two things are the same exact. This is just the simplified version. And then here, because all three, because all three of these things share a 2 in common, I can actually reduce that. Divide it by 2, divide by 2, divide by 2, and I get 2 plus or minus. That's a 1. 1 square root of 31 is just the same thing as the square root of 31 over 3. That's one way they might write it. Another way you might see it as 2 over 3. Give this 3 to the 2. Plus or minus, give the 3 to this. Square root of 31 over 3. Those are both answers you might see on the SATs. How do we do?
Can we try one on our own?
We will at the end.
Okay.
Yes, Taylor, big time. In fact, we're going to do like 2 or 3 on your at the end.
Okay.
But did the process make sense?
Yeah.
The algebra 2 is not hard. If you get what I mean, the algebra 2 is just plugging in. In fact, really, there is no algebra 2 that you really can do this kind of on your own. It's just making all this stuff come together is kind of the algebra 2, which sucks. Meaning how to simplify this 124, order of operations, all that kind of stuff. And why was this different from algebra 1? Why couldn't you learn this fully in algebra 1? What did we recently just talk about with square roots that you didn't learn in algebra 1, you learned in algebra 2? What can happen with thing underneath square roots?
You can use I if there's a negative.
Yeah, we can get a negative, which you didn't learn about in algebra 1. So the reason we got to come back to it is there might be a negative when we do this b squared minus 4ac, which we're going to talk about in just a minute. If it kicks to a negative, it just means it's an imaginary answer, which you couldn't have done in algebra 1 because you didn't know about I. Hopefully that makes sense. Yes? All right. Let's bring this full circle. This is talking about stuff that's quadratic, yes? You guys with me on that?
Yep.
Okay. When I graphed this, this wasn't a 0. What was it normally?
-5.
No. If I graph it.
Oh, graph it.
If I graph it, what does this need to be? Not a 0, but a what?
A Y?
Yeah, because when we graph stuff, we need an X and a Y, right?
Okay, yeah.
You with me?
I'm following.
Now, what happens when I make this Y a 0? What is this equation really finding?
The X's.
The X what? If my Y is 0, that means I didn't go up or down. What am I finding?
It's the x-intercept?
Yes. So what does the quadratic formula find? It finds the x-intercepts for a quadratic formula. Does that kind of make sense?
Yeah.
When I solve by factoring, x plus 3x minus 4 equals 0. When I solve this by factoring, I am solving for the x-intercepts. How do I know? Because my y is 0. Are you with me?
Yep.
Well, let's look at this. How many x-intercepts does this question have?
2.
1 here and 1 here. Janina, how many x-intercepts does this one have?
1.
Good. How many x-intercepts does this one have, Annabella? Savannah, how many x-intercepts does this one have? Dominic?
None.
Right. So wait, if this quadratic formula that I just showed you is supposed to give my x-intercepts, how come there's sometimes it has 2? How come sometimes it only has 1? And how does it only have 0 intercepts? How does that happen? Why can there be 2? Can someone explain to me why you think there can be 2 x-intercepts? What part of this equation makes it to where there can be 2 x-intercepts?
Positive or negative? The plus or
Because
minus?
one time I add a number and one time I subtract it. So let's say the b was 10 and the plus the square root of 4. Well, what's the square root of 4 really?
2.
So one time I'm going to take 10 and add 2. One time I'm going to take 10 and minus 2. Do you see where you get split? One is 12 and one is 8. Those are 2 different answers. Do you get what I'm showing? So you see how there's 2 answers? Are you with me?
Yep.
So how in the world could I get just one answer?
If the discriminant equals 0.
Oh, you guys are from Roar, huh?
Krellin.
Oh, Crown, did you guys already do this?
Yeah.
Okay, so my kiddos haven't done this. So yes, this thing right here is called the discriminant. And what would happen if I had a 0 underneath it? What happens when I have, what's the square root of 0? What's the square root of 0? 0, right? So what happens if I add 0 to 10? What do I get?
10.
And what happens if I take 10 and I minus 0? What do I get?
10.
So notice how many different answers did I get when I had 0 underneath this thing, which is called the discriminant? How many different answers did I get? Only
1.
one answer. Is that making
So that's
sense?
only one x-intercept.
Right, there's only one x-intercept. Now, how the heck can I get 0? Well, these are real answers, by the way. This is 2 real. This is 1 real. This is 0 reals. Why? What would happen to the discriminant? What happens when I have a negative underneath the radical or underneath the square root? What pops out?
I.
And what happens when I have an I? It's no longer what type of number?
Real.
So we call this thing, like Kelly already said, this thing right here, this part of the quadratic is called a discriminant. It's the part that's underneath the square root. And what I'm telling you is, if you do this and you end up with a positive number, what do you know about the x-intercepts? How many are there going to be and what are they?
Two real.
And why is that? Because when I add, this is a positive number under here. That's still a real number. One time I'm going to add and get one answer. One time I'm going to subtract and get a second answer. That's why there's going to be 2 reals. Or I could get a 0 underneath the radical. And what happens when I add or subtract 0?
You get the first number you started with.
So you're going to get the same answer twice, because when I add it, I'm going to get an answer. When I subtract it, I'm going to get that same answer. So you're going to get 1 real root, and it's going to happen twice. It's called a double root. We're going to get to that a lot more in chapter 2. So if you see a 0 underneath this, if this turns to a 0, you know there's only 1 real root. And if it turns into a negative, you know there's 0 real roots. You know there's actually 2 imaginary. That is called the discriminant. The thing is, the problem is going to start out the same. The problem is going to start out like this. It's going to say 16x squared plus 8x plus 1 equals 0. That looks identical to the question, Taylor, that you asked. Hey, can we do another one? This looks identical to that one, doesn't it?
Yeah.
But the question they're going to ask you is going to be different. They're going to say, they're not going to say, hey, what are the x-intercepts? They're not going to say solve for x. They're not going to say that. They're going to say, describe the nature of the solutions, or what type of solutions would you have if I gave you this problem? So they're not asking you exactly for the answers, like what are they for sure. They're saying, how many reals are there? How many imaginaries are there? What kinds are there? Those are the questions it's going to ask. You'll see that kind of in homework. So that's what's going to differentiate CREP. Whether you're using the full quadratic or whether you're using what we call just the discriminant. And when I do the discriminant, all I'm caring is it positive, is it 0, or is it negative? Do you follow what I mean by that?
Yep.
Anyone else follow besides Robert and Kelly and Orist?
Yeah.
Okay. So what am I going to do? If they just ask me what are the nature of these answers, all I'm going to do is this part, which means I'm going to take the 8 and square it minus the 4 times 16 times 1. Does everybody understand where I got those numbers from? A, B, C. B, A, C. Just plugged in. 8 squared is 64 minus 4 times 16 is 64 times 1 is 64. 64 minus 64 is a 0. What does that tell me?
No, 0. Or
No.
one real.
1 real, and it's also called a what?
Discriminant or root?
Double root.
It's called a double root. It's called a double root. Again, I'm just prepping that for next chapter because that's going to come up again. So I like to preview some of that stuff. Try this one on your own really quickly. All you're doing is describing the nature of the solutions. All right, so all you should have done for this is you should have done b squared, which would be -4 squared minus 4 times 2 times 6, 25 minus that's 8. 8 times 6 is 48. Do I actually care what this number is? Like the exact answer?
No, you just care if it's negative or positive or 0.
And so I know this is going to kick out a negative, which means to me I have 0 real answers and I'm going to have 2 imaginaries. Because underneath my radical, I'm going to end up with a negative, which as soon as I do is going to kick me to the i's, which is in imaginary numbers. How are we doing on that? Does that make sense?
Yeah, makes sense.
That makes sense.
Questions on it? Does it make sense how it ties to graphing and all the stuff that we've done in the previous stuff? Here you go. Taylor, this is the one. You're going to try this one. I want you to do this fully out. The full quadratic. I want the x-intercepts. That means you got to do the full quadratic. All right. So if it was me, I label them. A equals 2, B equals 6, C equals 3. Then I would do opposite of B, negative 6. Oops, opposite of B, plus or minus the square root, B squared minus 4AC, all divided by 2A. Opposite of B, plus or minus the square root of 6 squared minus 4 times 2 times 3, all divided by 2 times 2. Does everybody understand how I did that?
Yep.
Yeah.
Negative 6 plus or minus the square root of 36 minus, that's 8. 8 times 3 is 24. All divided by 4. Moving on. Negative 6 plus or minus the square root of 12 over 4. Am I finished?
No.
What do I need to do?
You need to simplify it.
So I got to take this 12 over to the side paper and say, okay, how can I break down 12? 4 times 3, 2 times 2, and I get the square root of 2 squared times 3. How many times does 2 go into 2 without going over? Once, so I get a 2 out. How many times does 2 go into 1? It doesn't. Sorry, square root 3, you got to stay inside there. So I can rewrite 12 as negative 6 plus or minus 2 square roots of 3. These two things are the same exact number. Divided by 4. This, and this have something in common, so I can cancel it out. Remember, all three of them have to have it in common. 2 goes into it. 3, 1, 2. So it becomes a negative 3 plus or minus 1 square root of 3 is just a square root of 3 over 2. Or another way I could write it is negative 3 over 2 plus or minus square root of 3 over 2. Those are the answers that you should have gotten. Does that make sense? Yes or no?
I have a
Yeah.
question.
Yes.
Why, when you simplify the fraction, do you put it back in with a square instead of just square rooting it?
Are you talking about from here to here?
From the when you simplify it to the 4 and the 3, why don't you just square root the 4 and have the 3 stay in?
Oh, are you saying like up here when I'm doing factors?
Yeah.
Who's that? Is that Janina?
Yes.
Okay, so it has to do with, I don't like the way that they teach factoring. Do you remember me doing this in class where or simplifying square roots? It has to do with the fact that if you don't get the highest number in there, then it will make it make sense. It will make it fail. So I always go back to the prime factors, because if you do the prime factors, it will never fail you. So 12, I broke down to 4 times 3, and then I break down to 2 times 2, because these are prime factors. If I do prime factors, do you remember here? Maybe this will help you. Do you remember when you did fractions and you just started learning them? And I'm going to do hopefully an easy example. Let's say you did 12 over 16. And you reduced it by 2, and so you made this become 6 over 8. And your teacher went, nope, that's wrong. And you're like, wait, I divided them both by 2. That's what you told me to do, and that's 6, 8. And they went, no, it's not simple enough. Your answer should have been 3/4, because you should have divided by a 4 on both of them, because you have to get their greatest common one. Do you get what I mean by that?
Yes.
Okay, if you do this process with mine, the way that I'm doing it, you will always pull out everything you're supposed to. If you don't do it this way, there's a chance sometimes that you leave a square root in there that you should have pulled more stuff out from. If you go to the prime factorizations, you will always pull out everything you're supposed to.
Okay.
Sometimes people do, I'm going to try to think of one, like 32. You can rewrite 32 as 32 or as 4 times 8. And then you can take the square root of 4, which is 2, and then some people might write 2 square roots of 8, and that's the wrong answer. Because it should have been 4 times 8, 2 times 2, 2 times 4, 2 times 2. It should have been 2 to the 5th power, which means 2 goes into that 2 times, so I should have got 2 squared out. Square root of 2 left over. 4 square roots of 2 would be the correct answer.
Okay, that makes sense.
Because they just stopped at the 4 and they didn't realize, hey, there's actually another 4 inside there you could have pulled out, and that just happens. I'm giving an easy example. It's harder with bigger numbers. But if you do the prime factorization, it works even with the big numbers. I teach so that it always works, is the way that I try to teach. I don't try to teach the easiest way necessarily. Because as you learn, as you get higher, the numbers are just going to get bigger. And the way, when you do it the way I teach you, you won't make errors.
That makes sense. Thank you.
Questions?
Nope, I understand it.
I have a question.
Sure.
Well, it's not about like this problem, but for the assignment last night, I don't know where to find it, like in Canvas, like to submit it.